Hello, my name is Tayson from casaGeo, the data science and location intelligence company, with a second video on use the power of postgreSQL in Alteryx. Today I show how you can call a function in Alteryx. In the last video, you saw that the function produces two tables of results. First, the catchment area, and second, a table with all the nodes and the travel times for them. I present two methods how you can include the function in Alteryx. I use the first method to read in only one of the two result tables, either the catchment area or the table with the nodes. This method is very lean, as I only need the input data and the select tool for it. With the second method I show a possibility to read in both result tables in one step. The workflow is more complex, because we need all these tools. But I will show you a way to use the InDB tools for this. Let's start with method 1, we connect the input data tool to the PG routing database. Then we open table or query and here the SQL editor. The SQL statement differs only in one point from the select statement in SQL. Here we still have to use the functions st as GeoJSON, because Alteryx cannot recognize geometries that are in a select as such and then only returns a string. We can convert the GeoJSON back into a geometry in the select tool. If we run the workflow, we get the catchment area as a result. We change the XY coordinates once and move the location to Cologne. Run the workflow again. This fits. If we only need the nodes, we have to modify the input data tool a bit. We connect to the PG routing database again and select the video ISO lines table with the nodes. Now we need to add a pre-SQL statement. First, we delete the video ISO lines table, as we do not want to append the data. Second, we now add the select command from the last video. The command calculates the catchment area and recreates the video ISO lines table if it does not already exist. Since the pre-SQL statement is done first, we can read in the current data. We test the workflow. Great, that works. We do the test with the Cologne coordinates and run the workflow again. That works too. Now we want to read in both result tables and run the function on the postgreSQL database only once. I will show with the example of the second method, that is using the InDB tools. I start with the text input tool. Here I enter the parameters for the function, IDN, longitude, latitude, time, network, time distance, direction. Next we need the block until done tool. The block until done tool will ensure that the data is saved or loaded in the correct order. First, we store the data as a table in our postgreSQL database. We name the table video test. We open the postgreSQL statement window and enter the following SQL commands. Drop table if exists video ISO lines. Drop table video test. As in the first two examples, we want to delete the old file first. For this we need the output tool. In order to use it, we have to create a new table. However, we no longer need the table afterwards. Therefore, we delete it immediately. The second stream, which comes from the until tool block, will execute the postGIS function. We check the formats again in the select tool and dive into the database with the data stream in tool. We connect to the database PG routing. Here we can no longer work with a simple select, but create the table video input table. To do this, select overwrite table and write the table name in table name. In the formula InDB tool I create a new variable geom to which I assign the function. Since the InDB tools cannot read geometries, I convert the geometry into a GeoJSON with as GeoJSON. With data stream out I pass the result to Alteryx. In the select tool I convert the GeoJSON into a geometry. The third stream from the block until done tool has only one purpose. We use it to make sure that the nodes are only read in after the calculation of the function has been performed. In the Select tool we select the variable ID, and in the data stream in DB we create a temporary table. This will be automatically deleted by the system later. Now we need a Connect in DB tool to load the video ISO lines table. Of course, we also need to connect to the database here. In the Join in DB tool, I use the record ID to match the two tables. As I said above, I only do this to make sure that this step is done last. Therefore, I can delete the duplicate ID in the Select tool. In the Formula tool we convert the geometry into a GeoJSON, and in the following Select tool I rename the variable from new geom to geom. With the Data Stream Out tool we pass the data to Alteryx and convert the GeoJSON back to a geometry. When we run the workflow, we get both results in one run, even though the function is only run once on the postgreSQL database. Again, we can run the test with the colon coordinates. Great, it works. That's it for today. In the last video in this series, I show you how to create macros from the 3 workflows. Today we went a little deeper, but I hope you enjoyed it. Then give us a like, and if you are interested in the topics of data science and location intelligence, then subscribe to our channel. Thank you very much for your time.